Regulations of Genetically Modified Plants in South Africa by Dian Kwapa in LST 110 Group 21. Chosen text is published 15 February 2022 in The Conversation. It's about how regulations and laws of genome-edited plants affect South Africa. It argues that South Africa's regulatory approach to genome-edited plants is outdated and overly restrictive, and how genome-edited plants are wrongfully classified. This text is relevant to my field of study because the restrictive regulations discussed hinders innovation amongst local communities. The text is up to date. It was published in 2022 and discusses decisions made in 2021. As of 2025, genome-edited plants are still governed under the GMO Act 1997. The information in this text are important to those in the agricultural, biotechnology and food security fields, as it contains information on the regulations of genome-edited plants classified as GMOs. The authors are J.R. Lloyd, a professor of the Stellenbosch University, Dave Berger, a professor of the University of Pretoria, and Priyan Pillay, a senior researcher from the Council of Scientific and Industrial Research. The text provides scientific evidence. It discusses how genome editing allows for the development of crops that are resistant to pests, diseases, and climate change, and it also discusses the evolution of genome editing from traditional plant breeding methods to modern genetic engineering techniques. The purpose of this text is to inform those in the relevant sectors of the agricultural world and the people who contribute to the food security of South Africa. The authors are possibly biased and advocate for genome editing and new breeding techniques as essential parts for food security and progress in the agricultural sector. To support its argument, the text makes some key claims. Claim number 1, that genome editing is essential for improving food security. According to Tawari et al. 2020, it provides evidence that proves the claim, since genome editing allows scientists to grow crops that are resistant to diseases, pests, and environmental stresses, and it accelerates the development of high-yielding crop varieties. And the reasoning behind this is that this ensures food production even in challenging conditions. Claim number 2, that strict regulations hinders local innovation and discourages investment in better technologies. According to Laswed et al. 2021, it provides evidence that proves the claim, since strict regulations puts financial and administrative burdens on scientists and companies, making it difficult to develop and commercialize genome-edited crops. Restrictions will prevent businesses and researchers from developing technologies that would be improvements to agricultural technologies, and this hinders their effect on the economy. I challenge claim number 1, that strict regulations will discourage local innovation and investment. According to Sprink et al. 2022, it provides evidence that several countries, including Canada, Japan, and Australia, have adjusted their regulations to accommodate genome editing, demonstrating that regulatory frameworks can evolve without necessarily suppressing local innovation. If regulations are clear and well defined, even if strict, it can provide clarity for investors and researchers, and it can foster structured innovation. My source is Genome Editing Around the Globe, an update on policies and perceptions by Spring T, William R, and Harton F in 2022. Challenging claim number 2, that genome editing is essential for improving food security. According to a study by Gomiera in 2016, regardless of any genetic modifications made to the soil health will still be reduced, and this reduces agricultural productivity. The study warns that focusing on genome editing without addressing broader ecological concerns, it may lead to unintended consequences such as biodiversity loss and an increased reliance on industrial agriculture. The argument in the conclusion is based on a thorough look on how genome editing affects things, including potential for unintended genetic changes and the bigger picture of food security issues. My approach to this argument has been shaped using the CRAP analysis, and I concluded that the information presented are credible and verifiable. I challenge the argument based on counterclaims substantiated by research and evidence supporting these counterclaims. This is an important field in biotechnology because it integrates in many fields, including the agricultural sector, and this directly affects food security. Here are my references for the texts used in the presentation and the other texts used in this presentation. Thank you.